Good afternoon. My name is Maria Cordielos, and I am the Executive Director of the IGES Institute. Welcome to the XML Basics for NIBRS implementation. As many of you who have gathered here today are aware of, the IGES Institute is an organization that has been around for about 22 years, and it's supported the public and private sector in many ways. For those of you that are new to the group, we thought we'd spend a couple of minutes just reviewing a couple of slides, reviewing the concepts of IGES, its history and its purpose and goals, and then lead into what is the coursework for the XML training sessions. If you bear with me, I'm just going to show you a couple of slides. I'm going to go to share screens. So as I mentioned, we'll go through the IGES Institute and chat about a little bit about its history and its goals and objectives. The Institute is a nonprofit collaboration network, and what that means is that the community that it serves is part of the community that is part of its suite of services. It is made up of not only public sector practitioners on the federal, state, county, local level, as well as the service providers that support the mission space in order to maximize safety, efficiency, and productivity in the communities nationwide. How we do that with all those members at the table is by advocating for policies, processes, and information sharing standards. What that means is that from a federal perspective, state perspective, often county and local perspective, there are many policies that work in harmony. There are, in fact, however, many policies that seem to compete with one another or sometimes contradict one another. In order to implement an effective information sharing standard program, we, the IGES community, become very fluent in what the policies are for the respective program and ensure that there is an alignment not only built into the solution set, but into the programmatic framework that then ensures success. We also need to understand the processes that are mandated at the federal, state, county, or local levels. Again, we're here to support the mission objectives of each of those agencies, whether they come from any one of the criminal justice silos or any one of the civil justice silos or any one of the public domain entities that we service. From a technical perspective, we are tool agnostic. We have many different private sector entities that are part of our membership, but we all agree to move towards information sharing standards. And what that means is that we go towards a common bridge of understanding and sharing data elements that are imperative to support the priorities of the operational entities. Given the 22 or 23-year history of the IGES Institute, we have developed over time, we have expanded over time, we have refined our mission over time. That has unfortunately and fortunately been driven by the world events that we have witnessed, participated in, been victims of, or been responders to, from 9/11 to Katrina, to Hurricane Sandy, to January 6th, to the changing technology, to the school challenges and violence that happens all too often, and most recently, even the pandemic. As the world changes around us, so too does the need for data availability, sometimes as quick as possible, but most importantly, as efficiently and as effectively as possible in order for decision makers at the federal, state, county, local levels to make wise choices. Those domain areas that the IGES Institute started by supporting and continues and develops to support over time, started with the traditional justice members of law enforcement, courts, and corrections, and over time has expanded to fire, emergency management, emergency medical services, homeland security, to reflect not only hometown, but homeland security, health and human services, school safety, and critical infrastructure, to name only a few. The secret sauce as it relates to the IGES Institute speaks to the public and private partnership that is part of that broader membership that I made reference to. From an organizational structure perspective, we have the IGES Board of Directors that is represented by the private sector members that are elected on an annual basis, and soon to be a Board of Advisors that will represent the public sector entities of some of the domains that we service. The work and collaboration and partnership that happens on an ongoing basis is often witnessed at our advisory committee tables. We have the traditional law enforcement and criminal justice advisory committees that represent business done at the local and the federal levels. The courts and the corrections committees that speak to the broader communities. Recently, and I say in terms of the pandemic, we stood up what was an emergency communications and response advisory committee that spoke to the changing time and dynamic between the emergency communications centers, the old PSAPs or public safety answering points, and how they have emerged to become more like real-time crime centers. And that may be, that certainly represents a paradigm or a spectrum of progression over time in many different jurisdictions, but it once again reflects how important data is to the responders at all levels. We also have an information technology advisory committee that speaks to the emerging technologies that are available to all of these public sector entities and domains. Again, as much as the tools and the technology is critical to successful operations, it should not be the be-all, end-all. It must then support the policies and processes that I made reference to earlier. Finally, we've recently stood up what is a data analytics advisory committee, and that speaks to the slicing and dicing of data that happens for so many purposes, whether that is a national perspective to deal with homeland security issues, be that national or international, whether that is state or regional issues that then speak to fusion center issues that are dealt with on a regional basis, or whether that is crime analytics that may happen for a particular jurisdiction. All of those committees and all of those abilities to be able to utilize the data are then assessed, and processes are built in order to facilitate those matters. I'll reiterate here that the individuals and volunteers at those tables, again, represent the totality of the IGIS community that is very, very broad and comes from national and international players. It is the public sector entities, it is the practitioners, it is the private sector members with the solution providers, it is standard development organization, researchers, statisticians, academics, and many, many more. Finally, by way of services and engagement opportunities at the IGIS Institute, this event that speaks to the XML basics for NIBRS implementation is just one example of how we try to ensure that the changing needs of the public sector domain are met, supported, and success is ensured by delivering different training and technical assistance opportunities, program management services, and or different events and webinars such as this. So know that as I stop sharing my screen for just a moment, the critical value of the training that will now be presented to you speaks to an effort that has been a long-standing partnership between many of the nonprofit organizations and most importantly, the federal sponsors that come from the Federal Bureau of Investigation, the Bureau of Justice Statistics, in support of the implementation of the NIBRS program. As many of you know and well understand from this domain, the transition from summary reporting to incident-based reporting is one that has been going on for decades. I want to say the most recent generation was in 2013 with the constitution of the NCSX program, or the National Crime Statistics Program Exchange, that then spoke to focusing on 400 sample agencies that both FBI and BJS supported the implementation in order to realize statistically relevant data from national trend creation and patterns to understand. That was then followed by many grants supported by those same agencies and more in order to implement NIBRS on a national basis for the remaining of the 18,000 agencies. RTI, Research Triangle International, is a group that led what was that NCSX program, coupled with many of the partners that included the IGIS Institute, the Search Organization, the IACP and PERF organization, as well as ASUCRP. With all that, you'll see that the constitution of players, even at that table, spoke to all of the process issues, the policy issues, the technical issues, the program issues, the training issues, etc. With that in mind, one of the last deliverables that is part of that NCSX program is the delivery of this XML Basics for NIBRS implementation. Though it is one that is critical to agencies at local levels, of course, your level of understanding from an agency perspective or from a service provider perspective may be at the beginning of the spectrum, may be at the intermediate level, or maybe at the advanced level. For that reason, we have 3 different levels that this introduction will service to bridge for you. And we hope that each of the courses provides you great value to you and to your peers. Know too that we are welcoming what will be questions over time. And with that, we will assemble and then produce what are FAQs that will be available at the IGES Institute website. Today, we have Tom Carlson of Tom Carlson Consulting that will be delivering the curriculum for us. For those of you that have been part of the justice domain the last 2 or 3 decades, you'll recognize the name, the skill set, and the accomplishments of this individual that has been part of the NIEM, or National Information Exchange Model programs. He's been involved with several different organizations, be they at the federal, state, county, or local levels, and he has been instrumental in their success. He will be the MC, he will be the curriculum development individual, and he will be your moderator for the basic, the intermediate, and the advanced courses. We look forward to the questions that you have to ask of him. We ask that you provide those questions through info@iges.com. And we once again thank you for being part of this program. Take care and see you soon.
So let's take a look at XML Schema. So XML Schema is a means of defining what an XML instance document needs to look like. So we've been looking at our example here, right? And what tells us what the different pieces are and how they need to fit together, well, that's the XML schema. So there is XML schema that says, hey, the first level element here needs to be a submission, and inside there needs to be a message metadata, and inside there needs to be a message date time and a message identification, and inside message identification is this identification ID, and the date time here needs to be a string like this. These things are all defined in the XML schema. So let's go back to the notes here and take a look. Before we get to that though, we do need to note that XML schema comes in 2 versions, 1.0 and 1.1. 1.0 is much more powerful than 1.0, but it doesn't enjoy broad tool support. You're not going to find a lot of training or materials for it. We're going to be looking at 1.0 only. That's what we use. That's what NIBRS uses. That's what NIBRS uses is 1.0. Most XML schema that you're going to see in the real world is using 1.0. But just so you know, there is a 1.1, but nobody uses it, even though it's got a lot more power to it. So here's just a quick look at the top level schema for the exchanges we just looked at, and you can see it has its own root element. We're going to go through in more detail as we go. This is just kind of a quick, let's take a look at a whole thing here and get an idea. So it starts with a schema tag. It has a bunch of attributes here. We don't know what these attributes mean yet, but we'll find out. We'll get there. It has a thing called an annotation, something called a documentation inside that seems to have a name for it. Cool. It has a bunch of import statements. What are those all about? We'll find out. We'll get to namespaces, and that's where we'll go through what these different things are. Has something called a complex type here. That has some sort of documentation to it. That's got an extension of some sort. There's something called a sequence, and that's got a bunch of elements inside of it. And if you're kind of looking closely, you're going to see things like, oh, it's a report type. That's interesting. And it has things like a report header and an incident and an offense. You can kind of just see by eyeballing it that things kind of start to fit together. But we're going to go through in more detail, so don't stress yet. We're just taking a look. And we go down and there's more complex types. Here's submission type. Well, that sounds like it might be related to the submission itself, which is the root level of, again, of our example here. is that submission object. That's interesting. And we can continue down. So here's the submission. Oh, and look, the submission has a message metadata and a report. So just looking here, we kind of get a clue that this is something akin to what we see in the actual exchange in the instance document. A submission with a message metadata and a report inside. Now we'll go through the details of this, but just right away you can kind of see, oh, I kind of see how these things fit together a little bit. Then after all these types, we've got elements, and here's an element name, victim to subject relationship code, and a charge UCR code. If we go down further, we'll find like a location category. Hey, we remember there were location categories, right? We looked at location at the location element at some point, and we saw that it had a category code inside of it. Cool. See, that's where those things are being defined. Now, again, the details we'll get to. I just want you to see at a high level, and we keep going down. Eventually we go, oh, here's submission of that submission type. And we go, oh, that's probably linked to that submission type we saw above that told us what a submission has inside. So you can kind of see, now there's more to it. Let me show you real quick. If I go over to my XML editor, this is the same schema here, just in my XML editor, and all the same sort of things. But there's more to it as well. There's also one with code table entries in it. We're going to learn more about code tables. And there are additional support schemas. If I click, for example, on this organization type here, basically I do a control or a command click on that, and it will load up another schema that has some more additional information about it. So there's more than just this one schema defining this. There's a whole set of them. But once you understand how this stuff works, it's not hard to piece together how all the different pieces fit together. And an XML editor helps you with that, to get examples together before you actually jump into development. And there are plenty of development tools that will take the schemas and create the program hooks for being able to create and consume those documents. We're not getting into any of the implementation details here. Here we just want you to learn about XML and XML schema, so that you can go on and work in whatever development environment you work in. So that's just a really quick look at a schema. Now let's start talking about the different kinds of things in it. So there's different kinds of content in XML schema. Some things are simple and some things are complex. Simple content just holds things we think of as simple data types: strings, numbers, booleans, dates, things like that. For example, in our example, NIBR's report category code holds simple content. It holds a code table entry. It holds a short string. That's all it holds. Nothing more, nothing less. It just holds a string. Complex content consists of other objects. I've got one object and it has other objects inside. The one we've looked at the most has been submission, the root element of the example, and it holds things like the message metadata and a report object. And each of those, in turn, contains other objects as well. Message metadata, for example, holds that message datetime and holds that message identification. Also holds a message implementation version and a message submitting organization. It's complex. It doesn't hold simple data types. It holds other objects. And those objects, in turn, some of them can be things that hold simple content, and some of those can, in turn, be complex and hold complex content. You can also have what's called mixed content, and that's where objects can hold plain old simple data as well as more objects, more XML tags. And HTML and its XML equivalent, XHTML, is a good example. You see this kind of thing a lot. There's a P tag, and inside the P tag is a string, but also inside the P tag is a strong tag to mark this text as strong, and an ending strong tag. It's a mix. The P tag holds both the strong tags as well as the strings. That's supposed to be strings. Sorry, that's a typo, and I missed it because I was dealing with the word strong here. Just glanced over it. So the P tag holds mixed content. Now we're not going to talk about mixed content because mixed content is really for documents like HTML documents. If you're going to show an HTML document, we're talking about XML in an information exchange context, which is very different. You don't typically see mixed content in information exchanges because mixed content can be difficult to handle. So information exchanges, you're going to see either simple content or you're going to see complex content. You're not typically going to see a mix, and you're definitely not going to see a mix in NIBRs. So we talked about these two different kinds of content. We have different kinds of types to handle those different types of content. So remember when we looked back at, oops, that's not where I wanted to go. When we looked at the XML editor and we were looking at the NIBRs top level schema, and we had different elements, and then we had different types that went with them, and we have types here. And some of the types are designed for complex stuff, and some are designed for simple stuff, and some are defined for kind of a mixture of both. So we have types to handle simple content and types to handle complex content, but it's not a simple one-to-one. There's actually 3 different combinations. So let's go through each of those. The easiest one is just a simple type with simple content. So it's a type that all it does is hold simple content. It might hold strings, might hold integers, might hold decimals, might hold dates, might hold booleans, and booleans in XML are literally just the strings true and false, all lowercase. Nothing else works. It has to be true or false. Can't use ones and zeros or anything like that. The string's true and false. But these are all simple data types, and so simple content that would hold these things can be defined with a simple type. XML Schema then redefines these types into many varieties. So there's an integer type, but it can be refined into, for example, non-negative integers for something representing quantities. You know, how many widgets do you have? Well, you have 0 to infinity, but you don't have less than 0 in terms of quantities. Dates are just strings, but they come in many varieties. Some with the date and time, some with just a date, and various options. They all are strings, but XML Schema modifies those strings to match certain patterns to represent different ways of showing a date and time. Now, XML Schema validators will check that the simple data follows the rules for that particular data type. If you want a real quick example, we can go to my XML editor. And actually, I don't have the example up there, so I can't show you in my XML editor, but it'll check that kind of thing. So if I was in here and I changed, this is our, our example document, and I changed something so that it didn't work anymore. I stuck a X in the middle of the month here. Oops. But I have to be in edit mode, not in presentation mode. So if I put an X there, a validating editor would give me an error, and it would say, hey, this isn't a valid string type, or this isn't a valid date format. So these types are all defined in XML Schema. And validators, XML editors, and there are command line validators, as well as validators that get integrated into your development environment. They'll check for those sort of things. So if you say this string has to actually, this data, the simple data has to be an integer, and you feed it something that's not an integer, it'll complain about it. If you say it's a decimal and you give it a normal string, it'll complain about it. Or you give it some list of numbers that doesn't actually represent a decimal number, it'll get mad. If you've got a Boolean and you try to use a 1 and a 0 instead of true and false, it'll get mad and it'll tell you about it. So these things, the validators check these things. So any of the elements in our example that hold text, for example, are a simple type. And here's just one example. Here's that identification ID. We saw it up here. Here's one right here. For organization, OR identification has an identification ID inside. It's just a string. This is just a random fake ID, but it's just a string. And the typing for that looks like this. Here's an element. It says, hey, this is XML Schema. It says, hey, we're going to create an element. Its name is going to be identification ID, and its type is going to be a string. Now the stuff, the name-xs colon, that's namespace stuff. We will get to namespaces, but that'll be a little further down. We're not to it yet, but just know for now it's a string. Hey, this identification ID is a string. You get a little more than that too. You get this annotation with a documentation tag, and this is where you put the definition for that element. So if you need to know a little more about it beyond the name, you find it here in the documentation tag. This one isn't particularly useful. It's an identifier. Okay, that doesn't tell you a whole lot, but other things have a little bit more to them. So that's simple types with simple content. It's just a string, a number, a date, something like that. Then we have complex type with complex content. Instead of simple data, an element contains other elements, and you need a complex type to represent that complex content. So here's a version of incident augmentation from our example. It's just an element that holds some other stuff, and here's what it looks like. Here's my element, and it ends down here, and it has a name, incident augmentation. And then inside the element tags is the definition of a complex type. Now, if you're really sharp-eyed, when I was showing you the schemas over here, you'll notice that things were a little different. Elements had a type name instead of having it inside. And if you're that eagle-eyed, congratulations, you're very eagle-eyed. And paying attention, if you missed that, don't worry, you were supposed to miss that. But just in case somebody noticed, there's more than one way to define these types. And we're starting with the simplest way, which is just to define the type inside the element it applies to. So here we have an element, and inside of it is a type being defined. It's a complex type. It's going to define elements that hold other elements. It's going to define an object that holds other objects. So it's a complex type. What kind of content does it hold? Holds complex content. It holds content that are other objects instead of holding a string. And then we have something called a sequence. And the sequence says, well, what kind of complex content? And it's basically a sequence of the things inside the sequence tag. So first you got to have an incident report date indicator, and that's a Boolean, so that's going to be true or false. And then you have to have an offense cargo theft indicator. And again, that's a Boolean, that's a true or false. There's some other things off here. That's for cardinality. We're going to get to that in more detail in a little bit. But right now it's, hey, we have an element called incident augmentation. What goes inside of it? Well, it has a complex type that holds complex content that is a sequence of two elements, the incident report date indicator and then the offense cargo theft indicator. And they have to be in that order. It's actually a sequence, has to be in that order. And if you went and looked around in the example here for an incident augmentation, I'm not sure if the example actually has one, because I don't have them memorized. But you would see, I don't think this particular example does, you would see that. You'd see an incident augmentation with these two elements inside. Now this was a really simple example where the two things being held inside were both simple content. They were both Booleans. This one's a Boolean, and that one's a Boolean. If we go up one level, we'll see a little more complexity and a mixture of complex and simple content. So here is incident that holds these various things. So we've got an element, and its name is incident. Now again, this is XML schema where we're defining what the objects need to look like. The element is called incident, has a complex type, which starts with a sequence. We got an element, activity identification. We have a second element called activity date, and a third element called incident augmentation. And now these all have types of their own, an identification type, a date type, and an incident augmentation type. And these things are type definitions somewhere else. So here we did things, these are just really simple types. They're built in, they're just Booleans. Here we're actually referring to other types that are defined elsewhere. And so you'll see that when we look at the XML schema again, that you've got these various types being defined here. And so here's a report type, and it's got all these different elements, and these elements are all going to have their own types, which are down in this case listed down here with the different elements. A reporting agency has an organization, is of organization type. So again, let's go back to here. And note that incident holds a variety of objects. They're not simply guys. There's activity identification. That's identification type. It's not just a string. Activity date is of a date type, which is not just a string here in NIBRS. It's easy to think that's just a string, but it's not. It's actually a date type that then holds different representations of a string representing a date. And the augmentation, which was just right up here. We had the augmentation right up here. So these are all complex things inside the incident. So what this ends up making is, and again, this is a simplified example from the full example, just so we can have it on the screen and take a look. But if we add all that together, we have an incident, and inside the incident is an activity identification, that activity date, and the incident augmentation. And if we look up at the earlier little example, we see the incident augmentation holds those two indicators. And so those indicators are actually not in this example. I pulled this out of the actual real example. So this one's a little different. But it has the incident, the activity identification, the date, and the augmentation. And the augmentation, each of these are complex. Each of these hold their own sets of things inside of them. And then inside of there, some of them are simple. This is a simple content here. But some of them are complex again. This is complex, but this is complex. And then it has this inside, which is simple. So it can be a mix. You got complex types and simple types, and they all get mixed together depending on how you define them. Third option is a complex type with simple content. So a complex type with simple content is when we have a type that is just simple content. It holds just like a string, but we also want it to have attributes. And in order for it to have attributes, we have to turn it into a complex type. It has to be complex. And so here is just a really quick example. Here we need, if we wanted to add some sort of attribute to victim sequence number text. So we got a victim, it's got a victim sequence number text inside, which is just a string. In this case, the string happens to be a number, but it's just a string, and it's the number 2. What if we wanted to be fancy though, and we wanted that to be other number formats? Well, we could add an attribute to it. We could say, hey, victim sequence number text, it's simple content, but instead of a complex type, simple content with an extension extending from string. And this is the first time we've really seen extensions, but this says take some existing type and add some things to it. And so what we have here is an extension of string, because this is a simple type. This is, well, it starts as a simple type. It's just an object of simple content, holds a string, so it's string, but then we add something to it, we extend from it, and we add this attribute called number format that is also a string. And now we've created a new type, a new kind of element that is a complex type with simple content because it also has an attribute. And if you do all that, then you will be able to do something like this instead. Victim sequence number text, number format, and then maybe Roman and II instead of the number 2. Made up example. This is not out of NIBRS at all. I mean, you know, the names of these are, this is in NIBRS, but it doesn't have this attribute. This is just to show that you can add attributes to elements that hold simple content, but you do end up making a complex object out of them. Complex types with simple content like this can cause issues when moving from XML to other serializations, such as JSON or RDF. These other serializations treat data as either objects or simple data types. There's no in between. There's no concept of a simple object with attributes added to it. That just doesn't exist in other serializations. So if you're working also with JSON or something like RDF, a YAML is another example, none of these handle this situation well, but NIBRS is XML only as far as I know, so you don't have to worry about it unless you're also working with JSON or RDF. Otherwise, this is perfectly fine stuff in XML, but XML can do some things that other serializations can't, and there's good reasons for sticking with XML, even though it's been around for a while. Let's revisit our schema example now and talk about the different types of compositors, the different ways to put things together. Now we've seen one, and it's called sequence. And here's a good example of it. Here's a report type, and it is a sequence, and the sequence has all of these things in it. These are all the kinds of things it can hold in this order. It has to be a report header first, and then an incident, and then an offense, then the location, but it has to be in that order. But there were other ways to do it as well. So let's scroll all the way down and get past the schema. There we go. But note that each one of these complex types, and I only showed one, but they're all like this because everything in NIBRS is like this. Everything in NIBRS uses sequences. So I do want you, however, to know about some of the other ways of putting together objects inside of a complex object. So sequence is the one NIBRS uses, I think, exclusively, and it means exactly that. It's a sequence of elements. This object can hold A, B, and C in this order. It's very clear what's going on. You'll see sequence a lot of the time. So sequence is easy to understand and parse. That's why we use it. Lists the elements that need to be inside of this object in the order they need to be in. If something required is missing, you'll get an error. If the elements are out of order, you'll get an error. It's really, really good for information exchanges when you want to sharply and strictly define what the exchange can have. You want to define it tightly. Sequence is good at that. Another option is choice. And what choice does is it lists a whole number of elements, and any one of which needs to be in the instance document. So you can give an example, you can give a choice of like different data formats. Maybe you have a string version of something, maybe you have an enumeration, maybe there's just your use case is that you'd only want one or the other, and so you have this choice compositor that says, hey, this complex object here can contain this or that or this other thing, and you pick whichever one of the three. They can all be in there. The problems with this are that you're not as tightly defining the exchange. It's a little looser. There may be good reasons for that. Again, you don't see this in NIBRS, but it's perfectly valid XML schema. NIBRS uses something called substitution groups instead, and we're going to be talking about those. Third compositor is the all compositor, which it'll list a bunch of elements, and they all need to be included, but they can be included in any order. So if you go up here, look at our example again, this one here for the report. If this were all instead of a sequence, then it would mean all these elements have to be there, but they can be in whatever order. It doesn't matter what the order is. As you can imagine, that can be hard to parse and deal with. So that's not very good for information exchange, and you don't usually see it. It can be very resource intensive to parse because there's just so many different combinations that are possible. It's okay if you're plucking one thing out of an exchange, but if you're actually trying to really parse through it and do all the checking, it can be a little more difficult to work with. And then the last one is called any, and the any compositor is a wild card. Anything can show up. So I can say this object can hold anything, and it's a wild card. Anything can go in there. Sometimes there's a really good use for that. If you want to, for example, include an arbitrary document inside a larger document, you can do that. But it's not great for data integrity, because in data integrity, in information exchanges, you really want to know what's coming down the line, because both parties need to understand what the data is all about. So allowing arbitrary data is not a good idea. But these are all perfectly valid choices in XML schema. Again, NIBRS uses sequence exclusively, but these other ones are available for other XML schema work. So now let's talk a little bit about cardinality. So cardinality is where we say how many of something can be inside of something else. And one example here in our incident with multiple offenses is we've got multiple examples of things showing up. As we're going through the report here, there's a location, and then there's an item, and then there's a person, and then there's another person, and then there's another person. And that's it. There's three persons, though, three different person objects in this one document in a row. And XML schema allows you to control how many of a thing can appear inside of something else. And it does it with minimum and maximums. It sets minimum and maximum occurrences. And the combination of that will imply things like whether something's optional or required, things like that. So XML schema doesn't mark elements as being optional or required. Other serializations do, but XML doesn't. XML schema doesn't. You get that information from the min and max occurs. So you've got an attribute called min occurs and one called max occurs, and they're used for this. Min occurs can be any non-negative integer, so 0 on up. You can't say you can have -5 of something, but you can have 0 to 12, to 100, to 1,258. Any number, any non-negative integer can be the low end, and typically it's going to be 0 or 1, but it can be any number. You can say that you have to have at least 3 people in person objects in this exchange. You can do that. Max occurs is the maximum number of times something can appear. And it can also be a non-negative integer, which means it can be 0. You can have a max occurs of 0, and that will work perfectly fine. It'll essentially forbid the element from appearing. I don't know of a good use case for doing that, but it'll actually do it. You do, however, max occurs has to be greater than or equals to min occurs. If max occurs is smaller than min occurs, validators will throw an error over that. But otherwise, just non-negative integers. Max occurs can also be the string unbounded, which means you can have as many as you want. It's like infinite, except for, if you actually had an infinite number, then your computer would crash, it would run out of resources. So unbounded is, there's no top bound, as many as you want. So min occurs, any non-negative integer 0 on up, and but typically 0 or 1, and max occurs any value, any non-negative integer, and also the string unbounded. So if min occurs is 0, that means an element is optional. If min occurs is set to 1 or higher, that means the element is required. And so instead of explicitly saying optional or required, you just do it with min occurs. If it's 0, it's optional. If it's 1, it's required. Max occurs can be set to 0. It's legal. No good reason for it, but you can do it. Typically, max occurs is going to be either the number 1, I only want to have 1 of something, or it's going to be unbounded. I can have as many as I want. In the NIBRS example here, person is unbounded. You can have as many people in the exchange as you need to represent all the people that are part of this particular exchange. There's no top end defined. So you can have as many as you want. There are occasionally examples where you want a max occurs that's more than 1 but isn't unbounded. A really good example might be address lines. A lot of different places have multiple address lines. I currently live in an apartment, so there's one address line for the apartment complex address, and then another address line for the my apartment number. I've got 2 address lines. So like a lot of systems are going to have a limitation, like maybe 3. Most systems that I've run into do not fully normalize addresses and don't have a separate address line table with join tables popping all these together. Now they got like 3 fields, you can have like 3 address lines. That's all you can have. So in a case like that, you'd want to have max occurs set to 3 so that people could send 3 address lines, but no more. If they tried to send more, the validator, the XML validator, would flag that as an error before it got actually to your database and you found out you didn't have enough fields for it. So here's just a quick example of a location type to represent a location, and it's got things like it's got a street address. We're just going to say that's a string, and we're going to say max occurs equals 3. So we can have 3 address lines. We've made it optional with min occurs as 0. We've also got a city, a state, and a zip, and we're going to say all of those are min occurs zeros as well. But you'll notice that there's no max occurs listed for these 3 here. What's going on there? Well, it turns out there are defaults for these. The default for both min occurs and max occurs is 1. So if there is no cardinality listed here, then the cardinality is 1 to 1. So no min occurs, it defaults to 1. No max occurs, it defaults to 1. And a lot of XML schema that you'll see in the real world will be like that. They really, here are the things we want, and we want 1 of each of these, and we don't want any less. They're all required, and we don't want any more. We just want 1. And so you'll see very simple cardinality that's just 1 to 1, and they'll just leave it out. Personally, I tend to put the min occurs and max occurs in, even if they're both equal to 1, because I hate relying on defaults when I can be clear about things. Certainly it doesn't hurt anything. But you have a lot of flexibility in terms of the range of how many times you want a thing to appear by using the cardinality. That said, the cardinality in NIBRS tends to be fairly loose. Again, if we go back to the XML, you'll see that these things are all pretty much unbounded. Not everything. You can only have 1 header, just 1. Min occurs of 1, max occurs of 1. It's required. You have to have it, but you can only have one. And that makes sense. You don't want to have more than one header block. It's kind of a one-to-one relationship here. But most of the other stuff, the incident itself is bound to one. That's important. It's important that there only be one exchange per incident. We'll talk about that a little bit more at the very end. That's important. One incident per submission. But most of the other things are very, very loose. Offense, you can have 0 offenses, you can have 1, you can have 5, you can have 112. There's no maximum bound. Same with locations, items, substances, and people, and enforcement officials, and victim subjects, arrestees, and arrests, and these associations which link these things together. We're going to see how in a little bit. But these things are all set with 0 to unbounded. They're all optional, and they're going to all be more than one. Now, nobody's expecting to get a submission with 145 offenses in it, but the XML schema doesn't forbid it. And NIBRS is kind of flexible by design so that it can meet the needs of the people who need to use it. So that's how cardinality works with elements. You got a min occurs and you got a max occurs. They both default to 1 if they're not there, but it gives you a lot of flexibility to mark things as optional or required and how many you can have. Attributes are a little simpler. An attribute can only appear in an element once. So if we've got attributes right here actually in the XML schema. Here's an element. This name attribute can only appear once in this element. Same for any attribute. You can't have multiple name attributes. Think back to the number format that the goofy number format we used. You could use Roman numerals. You can only have one number format attribute. You can't have multiple with the same name in the same element. So that means the cardinality is really just required or optional or prohibited, and I don't know what the point of prohibited is, but it's like the max occurs being equal to 0 as well. You can have the attribute defined, but you can prohibit it from being used in an element. So again, remember we had that table up when we talked about XML itself, and the table showed the differences between elements and attributes. This is a big difference. Elements can have fairly sophisticated cardinality. Attributes are just required, optional, or prohibited. There's nothing else to it. If no cardinality is defined, the default is optional. So that's different than elements. Elements, the default is to make it required and make 1 be the maximum. But attributes, it's optional by default. So if you don't see any cardinality in the form of required or optional, it's optional by default. Now you've seen as we've been going through, and I've been going between simplified examples and this fuller example in my XML editor, sometimes things are defined in different ways. Sometimes you've seen elements with the types defined inside them. Sometimes you've seen, like in this schema, where there are separate types for the types and they're separate elements. And the hard part is the way NIBRS does it, which is based on the NEAM standard, is the most flexible but hardest to understand when you look at it format. And so I want the simple examples to be in the easier format. But now we're going to look at the different formats available so you can see how these things fit together and hopefully gain a better understanding for how the NIBRS schemas are set up and how they work. So there's a number of different ways to organize how your schema is going to say what an element can hold, especially for complex elements that are elements of complex type that are going to hold additional things inside. So the first way is the way that's easiest to read but least flexible, and that is anonymous typing. So anonymous typing is really the simplest way to do it. Each element tells us itself what kinds of things it can hold. There's no name for the type. It's anonymously defined inside the element itself. So here's a definition of incident done this way. Here's an element. It's got a name. The name is incident. What does it hold? Well, it holds complex stuff. So it's got a complex type inside. But there's no name. It's just an anonymous type that holds complex content that is a sequence. What is the sequence? What are the things in the sequence? Well, the first thing in the sequence is an element called activity identification. It's also of complex type complex content, has a sequence inside of it. What does it hold? Just one thing, an identification ID that's a string. And then we have all the closing tags all the way out to here. There's a second thing in the sequence of things that can go inside of incident. It's this activity date. And it's of complex type with complex content, holds other things. It's a sequence, one thing in the sequence, this date time of a date time type. So it holds a string. It holds that year dash month dash day, then the capital T, and then the hours, minutes, and seconds. That's the format actually. And then all the tags get closed off all the way down. And when you look at this, it's very, very clear what's going on. What does an incident have? Well, it's got this and it's got this. And what can those have? Well, it can have this and this one can have this. The XML schema structure mirrors the eventual structure of the document that validates against it. The incident has the two things in it that, when you look at this, looks like goes inside of it. And those things hold the things that are listed inside of it. It's very straightforward and easy to see, but it comes at a cost. When an element's type is defined inside the element, it has no name. So that means it can't be reused anywhere else. So if you have 5 elements all with the same type, you've got to repeat the type definition all 5 times. And anytime you decide to change how those elements work, even if they all work exactly the same way, you've got to go and change the type for each one of them. You're limited in what you can do. You end up having to repeat yourself several times. And when we look a little bit later at things like extending types to make them special, you can't do that either. There's just no actual type. There's just a description of how the elements fit together. And for a lot of purposes, this is just fine. So there's nothing wrong with anonymous typing at all. It may meet your needs most of the time, but it doesn't work well for NIBRS because NIBRS uses NEAM, and NEAM is designed to work in a different way. So let's look at a second way that gets us closer to how NEAM works. It starts to pull us a little bit away from what we're used to here. And this is how NIBRS does it. This is more flexible but less clear as to what's going on. These are name types. So we have a name type. This is the same example as up here, only done with name types separated out from their elements. So we define the types separately. We do have incident down here, but instead of incident having what it holds defined right inside of it, it just says, oh, I'm of incident type. And up here is where incident type is defined all by itself. Here's our incident type. And what does it have inside? It has one element, activity identification, and a second element, activity date. But wait, these aren't the actual elements being defined here. There's a slight difference that, unless you're looking carefully, you're going to miss. If we go up here, this incident holds this element, name equals activity identification. Name equals means I'm creating it there. That's where it's being created. It's different here. Here it's ref equals activity identification. This is a reference to somewhere else where activity identification is being defined. Where is it being defined? We go down here and we see element, oh, here is where it's being defined. Here is the activity identification, but it's name equals. This is actually creating it. And then it has a type, identification type. The type isn't embedded inside of it. The type is separate and it has a name, identification type. So we have to go and look and find that. Here's identification type. What does it have? It has a sequence with one element. The element is an identification ID, but this isn't a name equals. This is a reference, and it's going to point down to here where the identification ID is actually defined, and that is of a string. And the same thing happens with the date. Things of incident type hold an activity date. What do we know about that? Well, we have to follow the ref. We have to go find where it says name equals activity date, which is down here, and it is of date type, which leads us up here and says, oh, date type holds something called date time, but this is a reference to where date time is defined, which is down here. Here's the name equals date time, and it's of this date time, which is, again, the year dash month dash year, the letter T, and then hours, minutes, and seconds in 24-hour time. Okay, That is not at all simple. You can't just look at this, eyeball it, and go, oh, yeah, that means this. You can't, I mean, if you're really, really good at XML schema, maybe you can. I'm really good at XML schema, and I can't just eyeball it and put it all together like that. So this is very straightforward and easy to follow. But the name types are very flexible. There is a generic incident type. So we might have all different kinds of incidents. We may have a driving incident that can be of this type and get these same things. We can have a generic incident. We could have, I don't know, like a violent incident. We could have any sorts of incidents. Same with identification. This is an activity identification, but we could have all sorts of identifications. We could have a driver's license, and the driver's license could be of identification type. The idea being we can reuse these types. We can have one incident type and have different elements that are incidents all be based on the same type, so that we're not repeating this type everywhere. And if we make a change to incident type, it's reflected in every element that uses it. So it allows us to reuse that same type in different contexts for different elements that happen to be very similar in the kind of things they hold. But there's one more thing it gives us, and it gives us the ability to extend from a type to make something new that more closely fits our needs. So let's move on to extensions. But you need to have name types to do this. Otherwise, excuse me, you can't refer to the type otherwise. So for example here, and in fact you may have been wondering when we're up here and we're like, here's an incident. Why does it have an activity identification and an activity date instead of an incident identification and an incident date? Well, that's because incident is a special kind in NIBRS and in NEAM that NIBRS is built upon. Incident type is a special kind of activity, and it extends activity type to add new things to it. So let's look at here. This has been pulled out of the schemas but simplified so that we can actually go through it here. And we have two types being defined. So we have type number one is this activity type. And it's got a name. Name is activity type. It's based off something called structures object type. You don't have to worry about what that is. That's a NEAM thing. That is basically an empty object to start from. So it doesn't really bring anything to the table. It's just an empty object. So this is saying, hey, we got an activity type. It starts as an empty object, and it adds a sequence of two elements, an activity identification and an activity date representation. So anything of activity type can have these two things, can have the identification and have the activity date representation. Now this date representation gets replaced with an activity date. That's substitution groups. That's a little bit later topic. We're getting close to it, just so you understand how that becomes activity date. We'll find that out later. But then we have incident type. An incident type has a name. We're calling it incident type. It too is an extension. It's based on activity type. In other words, it's based on this type up here. It takes this type and it adds its own thing to it. In this case, it says I'm going to extend from activity type. I'm going to add a sequence of elements. In this case, I'm just one element called incident augmentation. That's all there is. That's the only thing I'm going to add. But now I've got a new incident type that has everything activity type has, but adds this incident augmentation. And then I'll make an element of it, of incident type, and that lets us do the following. The incident object inherits things from activity type. So here's our incident. The first things it has are the things it inherits. So it inherits this activity identification. That's this up here. Then it inherits an activity date. Now here it's called activity date representation. We're going to cover how that switch happens in just a little bit. But that's the activity stuff. Once it's had all the activity stuff, now we can move on to the things that are special to an incident. Here's our incident type, inherited all those activity type stuff, and then on the end it adds its own incident augmentation element. Excuse me. And so here it is here. And so what we have here is an incident with activity-oriented stuff. Incident is a kind of activity, but it's a special kind of activity. So it has this generic activity stuff, and then it adds in the special stuff that's specific to an incident. And in NEAM, the model that NIBRS is based on, there are all sorts of things that are special kinds of activities. And instead of defining a special date for each one of them, so there's an incident, and then that's going to have an incident date. And there's a crash, and so you need to make that with a crash date. And there's just there is like I'm blanking on it, but there are all sorts of different things that are forms of activities that all derive from that activity type. So the idea here is that you can take something generic, like this activity type, and make it special and meet your needs better by extending it to add additional things to it. And incident type can be extended from as well. So if you wanted, in fact, NEAM I think does it this way, if you wanted a special kind of driving incident, you could use incident as a base to make a driving incident. And then if you wanted specifically a crash, you could have a crash type that extends from the driving incident type, which derives from the incident type, which derives from activity type. So instead of having a separate crash date and a driving incident date and an incident date, they all inherit the activity date from activity type. And so it makes for a very flexible kind of object-oriented way of building objects, complicated specific objects from generic objects, without having essentially a data dictionary, a flat data dictionary. It's very, very powerful, but it does come at the cost of some complexity and at the cost of having to represent element typing like this with separate name types instead of something that's clearer at first glance. Again, anonymous types are very clear when you look at them, but they're not flexible. Name types are very flexible. Let's go to one more little example here, which is substance, which is something in NIBRS, and it's a special kind of item. So we got an element called substance. It's of substance type. So if we want to really know what a substance object can hold, we have to look at its type. Here's its type up here, substance type. It's an extension based off of item type. So there's something generic called item type, and it adds a category and a substance quantity measure to it. And if we go follow item type, that's up here. Item type is just an empty object, and to it there's a status, an item value, an item category, and an item quantity. So you've got generic item things, and then you've got more specific substance things, and that lets you have a substance object that can leverage the generic item stuff, but then also add substance specific stuff here, resulting in a substance object that looks basically like this. Here's a substance. First, it's got the generic item status. Then it's got the fairly generic item value. It's got an item quantity, and then it's got the substance specific stuff like the substance quantity measure there. And this way, you get to have this substance object that's detailed enough for what it needs to be, but it basically offloads generic things off to a more generic type. And item is really generic. All sorts of things can be based on item type. You got a car involved. That's a special kind of item. A vehicle, anything like that. Weapons are special kinds of items. Pieces of evidence can be special kinds of items. So it's very, very flexible, and you don't have to keep repeating these generic things that apply to more specific objects everywhere you have the more specific objects. So that gets us to our next topic. That's kind of what we've hit now is basic XML schema, and most XML schema courses, like you take XML schema in 30 minutes a day or something like that. Any of those kind of online classes will generally kind of stop here. They've taught you the basics of elements and of the typing and the cardinality and how inheritance works. And that's typically the stopping spot